Okay, starting out here in example 10, which is number 38 in the book, we're looking at videotaping and moving a car. And I just kind of drew the picture already, just kind of already have this drawn for you guys, but here's my car right here. It's moving towards, going from left to right across the screen, okay? And I'm going to call X just the distance as it's moving across there. Y is always going to be the distance between our camera up here on the top to the road. And Y is constant again. It's kind of just like the last problem where that was the height of the dock. Y is the distance between the camera that's recording this speed and the road itself. So that's always going to be constant, 132 feet. And I just let the hypotenuse this time be S because I just considered like line of sight maybe, just for S. You can decide what other variable you want to. But information they give us is the fact that the car is moving at a speed of 180 miles per hour or 264 feet per second. Now I chose to wrote it as 264 feet per second because our Y was in terms of feet, and so that way we can have all of our units all in the same unit. And notice how I put it as negative, and that's because I was considering the fact that the car is coming towards us. It's shrinking the distance along that road according to getting closer and closer to that Y-axis. So in part A, what they want us to do is, or I consider part A, is how fast is your camera angle going to be changing when the car is right in front of you? Okay, and then part B will be half a second later. So how fast is our camera angle changing when the car is right in front of you? Well, if the car is right in front of us, it's technically sitting right there, and so we can consider at that point X equals 0 because there's no distance between the car and being right in front of us on that Y-axis. It's almost right in front of us. Okay. All right. So now a formula, our base formula that we're going to use to take our derivatives. I'm just going to go because we have an angle, and specifically they want us to know how fast the angle is changing, so I should probably use an angle. I'll go with sine again, so I'll just say sine of theta is opposite over hypotenuse, so it's X over S. And if I go up there to take the derivative of sine of theta is cosine theta, making sure I do times then the derivative of my angle again, which is d theta dt. And then over here on the right, we're going to treat that as just 1 over S dx dt. And just finishing this out, getting d theta dt by itself. So we'll have our answer. We're going to divide by cosine theta. So it could be 1 over S times cosine theta, then dx dt. Okay. So going up there, I know dx dt, that's going to be the negative 264. Cosine theta, what would cosine theta? Well, cosine theta is always adjacent over hypotenuse. Well, adjacent is Y, hypotenuse is S. Well, when the car is directly in front of us, means that this hypotenuse has come all the way over there. So both of these are 132 and 132. So cosine theta, when does it equal, is basically going to equal 1. Okay? So that's just also knowing that S equals Y, which is equal to 132. So finishing this out then, d theta dt is going to be 1 over the 132 times 1, and then times dx dt, which is a negative 264. And it looks like we're going to get the answer of just negative 2. And because we're looking at the change in angle with respect to time, we'll just write it again as radians, but they don't give us exactly if it's degrees or minutes. We're going to go radians per, it looks like seconds. So there's the answer for how fast when the car is directly in front of our line of sight. So now with part B, what we want to do again is find the change in the angle, specifically when we've gone a half a second later. Okay, so right away when I think about this, it's basically now we're going to be looking off to the other side over here. Okay, and when we've gone specifically a half of a second, how far we traveled. Well, if the car is going 264 feet per 1 second, then in half a second, I actually technically know this distance down here, this x distance, because half of 264 is 132. So right there at a half a second later, I know my x distance is 132 feet per second. Okay, so now here's x, and then here's s this time. Or actually, we should probably be correct with our units, and x is just 132 feet, right? Not feet per second. And since y and x are the same, we can actually find s this time. So s is just going to be the square root of the sum of the two sides squared, so 132 squared plus 132 squared. And if we plug this into our calculator, we're going to get S to be approximately, looks like 187 feet. Okay, so now let's go and build off of our main formula. What main formula can we use? Let's do something different this time. How about tangent? So tangent of theta is going to be opposite of adjacent, so it will be x over y. Okay. And taking the derivative, so the derivative of tangent is secant squared theta, and then the derivative of our angle, d theta dt. Okay, over here on the right, just like before, our x is really our only variable, so the coefficient in front of it is y. So 1 over y, and then dx dt. Okay. And finishing solving for theta, we'll get, or d theta dt, we'll get it 1 over y dx dt. And when I divide by secant, or what we can think about it is more as, what if I multiplied both sides by cosine squared? Like that, okay? Because cosine squared times secant is 1, because cosine and secant are reciprocal functions of each other. And then in that case, I can make this numerator here cosine squared theta. All right, so now let's go through the challenge of plugging in all of our information. So d theta dt is going to equal to, I'm going to come back for cosine squared theta in just a second, but y we know is 132, and then x we know is 264. Okay. This time I'm going to treat x as positive, so I'm going to come up here and do dx dt, mainly because at this point the car has gone past us and now it's going away from us, so it's increasing its distance. So the change in the x direction is now positive because it's going further and further away. Okay, so that's kind of what you always have to do with these word problems. You have to really analyze what your variables are doing. Okay. All right, now let's go and find cosine of theta according to this new right triangle that we have. Well, cosine theta is adjacent, which is y, over hypotenuse, which is s. Well, y is 132. S, which was the square root. If I want to go ahead, I can put in there as that, this 187, but let's see if we can get it without too much of a rounding error. So it's going to be the square root of 132 squared plus 132 squared. And if I want cosine squared theta, then it's going to be 132 squared over the sum of those two, so 2 times 132 squared, which actually simplifies out really, really nice, because that will cancel with that and we'll just get 1/2. Okay, so cosine squared is 1/2. And just wrapping this up so we can get our final answer. And the change in the angle with respect to time, you get 1/2. That's going to cancel that, leaving 2. So 2 times 1/2 is 1. 1 radian per second. That's how fast the angle is changing when you've gone a half a second later. All right, next example. In this example, let's kind of go through it again and look and write out the key points and just see if you all agree with what I've written down right here. We've got a plane that's flying from left to right, and it's flying at a rate of 120 miles per hour. Okay, and then it's always flying at a height of 3 miles from the ground. So I said y is equal to 3 miles, and just to show that it's not changing, that I know that change in y with respect to time is going to be 0. Okay. Another thing they say that they're looking down and seeing a car, and the car is approaching at us. So the distances between the plane and the car are obviously shrinking, which would be x, distance x down there at the bottom. I used s as the line of sight, and so the question says specifically that when the line of sight is going to be from the plane to the car 5 miles, the change in the line of sight, so ds dt, is 160 miles per hour. And because obviously this is going to be shrinking, I wrote it as a negative 160. All right, the question asks us to find the car's speed along the highway. What is the car's speed? Well, we know that if this side is 3 and s is 5, then this is just another 3, 4, 5 triangle without any kind of conversions whatsoever. And if you want to check, just make sure, what is 4 squared plus 3 squared, does it equal 5 squared? 16 and 9 is 25, and 5 squared is 25, so yes, so x is equal to 4. Okay, so let's go into our main equation. What are we going to use? Well, we're not trying to find an angle this time, so I don't need to use any of my trig functions. I'm just going to use basic Pythagorean theorem. So we have x squared plus y squared is equal to s squared. and just taking the derivatives as I go throughout this, we have 2x dx dt. If I want to go ahead and write it as 2y dy dt, we can go ahead and do that. We just know that dy dt is obviously going to be 0 because the height is definitely not changing. That plane is flying that far up. And then 2s ds dt. Okay. Everything is divisible by 2, so we can go ahead and shrink that out and go ahead and take this one away. So x dx dt is equal to s ds dt. Or we can say then that dx dt is equal to s over x ds dt. Okay, so keep on going. Dx dt is s, which we said is 5, over x, which is 4, and then ds dt is negative 160. Alright, so this is going to get us a change in our x direction of negative 200 miles per hour. Okay, now we can't box that up though, because what that's saying is that the difference in the two directions, the distance in the horizontal x, is negative 200. And specifically, what it wants to know is to find the car speed along the highway. Well, this is where the plane is going to come in. If 120 miles per hour of that change is going to be plane, then for us to get up to a 200 miles per hour total, if 120 is the plane, then that means that the car speed has got to be the difference between the 200 and the 120, so the car speed is 80 miles per hour. And that right there is what the problem was asking us to find, specifically the car speed. Okay? And looks like we're done with this section, so we'll call it quits.